So the lesson today is honestly fairly important lesson in the big scheme of things. We learned about transformations of the graph of functions. And we do this with a lot of kinds of functions from beginning to end of this course. Today we start to explain it by dealing with one function in particular, and that's an absolute value function. So these are all coming from the SOLs, word for word, except for one thing. I did just substitute absolute value when they don't have just one kind of function. They got all kinds of functions, all the ones we're going to learn during the course. But right now, we could really only do absolute value. So we will learn some vocabulary here, like what's the parent function, transformations, things like that. Okay. Nobody wants to copy all that. So this is the pattern, right? When you get a new function, you usually plot points to determine the shape of the graph. Hopefully there's like a regular shape, and we can learn about the regular shape. And then ever after, we don't really have to plot points because we know the shape. But we have to start somewhere. So we're going to start by graphing the function f of x equals the absolute value of x by making a table of values and plotting points. So here's my table of values, right? There's my x values. We're going to calculate the y values. Where did I get these x values? I made them up, right? They're independent variable. We get to choose. That's the way functions work, right? We choose these. And I chose these because I know what the graph looks like. Okay, so now one at a time, we're going to plug in the -2 here and calculate the f of x, which will be our y value, right? So if I put in x equals -2, then the absolute value makes it +2, right? And if I put in -1, the absolute value makes it 1. And I put in 0, absolute value doesn't really affect it. Put in a 1, I get 1. Put in a 2, I get 2. So what are these here now? These are points, right? These are points I'm going to plot. So let's do that. Right. -2, +2. Right. -1, +1. 0, 0, 1, 1, 2, 2. Right? Can we see a shape in there? Yeah, it kind of looks like a V. So let's connect those with a line. And again, this is how we usually figure out what a graph looks like at the beginning, when we have no other way to figure it out other than put it in the calculator these days. But so we can see now the absolute value function looks like a V, okay? And it always will. If you get asked to graph an absolute value function and your graph doesn't look like a V, you kind of lost the biggest point of all right there. You've lost it. So I'm going to say more about the V on the next page. Right? So the absolute value function is a V. The point of the V right here, right, is called the vertex. Right? That is the vertex. Right? The graph of an absolute value function is symmetric with respect to a vertical line that's going right through the vertex. So if I draw, usually we draw it in as a dashed line, something like this. Then it's, in geometry terms, it's a line of symmetry, right? The shape is the same on the left as it is on the right. Mirror images of each other, line of symmetry. And actually, I should just be clear, we call it the axis of symmetry. When we deal with these shapes, we call it the axis of symmetry. Now, this particular function, y equals the absolute value of x, is considered the parent function for all the absolute value functions. You can consider them all together to be in the same family, but the parent function is the most basic, plain old absolute value of x. You know, as we have different absolute values, which are not exactly this one, you know, the v will move around the plane. Sometimes it'll be up here, sometimes it'll be over here, sometimes it'll be flipped. It'll be all over the place. We refer to the vertex with the coordinates h, k. Right? Let me go down here. Come on. Doesn't want to go. There we go. So these have the coordinates of h, k. Now the axis of symmetry is a vertical line going right through the vertex. So as we move this around the plane, there will be an equation for the axis of symmetry. What will it be? It's the equation of a vertical line. How do we write the equation of a vertical line? X equals, right? And now what does x equal if it's going right through a point that has the coordinates hk? I mean, on this one it's 0, but as we move it around, right, the coordinates of the vertex has an x coordinate of h. So if the line's going through hk, then this line has an equation of x equals h, wherever it is. And yeah, I mean, this one in particular has a vertex at 0, 0, and it's got an axis of symmetry of x equals 0. But it'll move around. That's what we're doing today. Notice if you look at this line here, right, it has a slope of 1. If you look at this line, it has a slope of -1. I mean, I've drawn very carefully. Up 1, over 1, up 1, over 1. Good. So now we need to figure out, okay, what do we do? How does it change the graph when we start adding numbers inside the function, outside the function, multiply the function, put minus signs in front, all this kind of stuff? The first one we're going to start with is the absolute value of x plus 2, right? Where the plus 2 is not inside the absolute value. It's after the absolute value. And again, let's just plot some points, see what happens to the graph. Right? When I plug in -2 here, again, absolute value makes it 2. And then I add 2, I get 4. Right, then I go to the -1. Absolute value -1 is 1. 1 plus 2 is 3. Right? Right. Then we put in 0, 1, and 2, and we're going to get 2, 3, and 4. So we'll plot all those points. -2, -4. -1, -3, 0, 2, 1, 3, 2, 4. Right. Do we see the V? Yeah, we can pick out the shape. It's there. So let's connect all these up. Right, there's our V. So what was the effect on the graph of adding 2 after the absolute value function? It went up 2, right? Right here you could see. Up 2. What do you think it would have done if I put -2 at the end of that? That would have gone down 2, right? So the general rule is this. Right? If you add or subtract a number after the function, that's a vertical shift. Plus means up, minus means down. And we refer to that shift as k, right? That'll end up being the y coordinate of the vertex. Okay. That one's pretty straightforward, right? Because if you had to guess, you'd say, okay, it's going up. Right? The next one's not quite so straightforward. It's the one thing that probably messes us up the most. You're done. Okay, let me know if I'm going too fast. So now let's do f of x equals the absolute value of x plus 2. Now the plus 2 is inside the absolute value. Now, let's see, I'm going to add to this here and show you what happens here. Let's say that I come up to this graph, and I say I'm going to just do those same 5 values, negative 2 to positive 2. Right? That would be this bottom 5 right here. Okay, plug in the negative 2. Negative 2 plus 2 is 0. Absolute value is 0. Negative 1 plus 2 is 1. Absolute value is 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. Okay, now I'm going to graph those 5. Watch this. So negative 2, 0. Negative 1, 1. 0, 2, 1, 3, 2, 4. See, it's these 5 dots right there. Do you see the V? Do you see the vertex so you could tell, like, this is a V and it definitely goes in 2 directions? Or all you see is a straight line? That's all you see is a straight line. You have to make sure if you're plotting points that you see the V, right? The vertex is the most important point, and you don't know it unless you've plotted something on either side of it. Then you can tell exactly where it is. So let's plot these two. If I put in negative 3 plus 2 is negative 1. Absolute value makes it 1. Negative 4 plus 2 is negative 2. Absolute value makes it 2. Now add those 2 points to the graph. Right. Negative 3, 1, and negative 4, negative 2. Now do you see the V? Yeah. So it's going to be right there. What's that? No, every graph does not go through 0, 0. So there's that, and there's that. So what did it do to the graph when we added 2 inside the function? It went left 2, right? We moved the parent function left 2. And that is probably, somewhat counterintuitive, because if you just looked at this and had to guess, you'd probably say, doesn't a plus 2 make you go 2 to the right? Isn't plus this way on the x-axis? Yeah, plus is this way on the x-axis, but actually the plus inside here moves it to the left. I mean, we can see that it does. I mean, why does it? Well, I mean, what's moving? Every point's moving, but just look what happens in terms of the vertex. The vertex is right on the x-axis, right, where y equals 0. So we need a value of x. This vertex is going to be wherever you plug in x here and get 0 inside the absolute value. Okay, what would you plug in for x to make x plus 2 equal 0? Negative 2. Negative 2 plus 2. So when it makes that 0, then the function equals 0. So it moves the function 2 to the left. Right. So you're probably going to be thinking, something doesn't look right about that, but it's that way. You have to get used to it, because it'll come up with every kind of function we study in the class. We're going to be doing these same transformations. They're the same, right? No matter what the function. So let's see. So this is the way we write it. We'll say if we add or subtract inside the function, that's a horizontal shift. Plus means left, minus means right. Now, if you notice, the way I've written it here, it could get confusing in terms of the sign. But look at the one that we just did. F of x equals the absolute value of x plus 2. If I said, based on this thing here, what is the value of h? Okay, well, remember, there's a minus right there. So really, this is like saying x minus negative 2. But since there's a minus there, there's a minus there. Now, what is the value of h? What is being subtracted? Negative 2. So the h, the x-coordinate of the vertex is actually negative 2. When you see positive 2, the h is actually negative. When you see it, if that was x minus 2, then the h would be positive. You know, but most of the time, you're just going to be looking in that. When you see a plus sign, you're going to think, go to the left. You see a minus sign, go to the right. Good. Okay. Now let's do another one, right? This function now, I put a minus sign in front of the absolute value. Let's see what that does to the graph of the function. And again, I've picked the negative 2 to 2 because I know what's going to happen here. When I plug in negative 2, right, the absolute value is 2. But there's a minus in front, so the value of the function is actually negative 2. Right? Again, when I put in the negative 1, I get absolute value as 1, and then I stick the minus on it, and it's negative. So we get these 5 values, which I graph, which I plot. Right? Okay, do we see the V? We do, right? But it looks like now that our V is going down. So how would you describe what looks like just happened to our graph? Yeah, most of the time what we say, you know, just the common talk is it flipped. It flipped across the x-axis. That's not what they say in the book. They call it a reflection in the x-axis. But if you say a flip across the x-axis, that's fine too. So this here looks like a flip. Okay. So that's what happens to the graph when you put a minus in front of it. It used to open up, now it opens down. We good? No? Good? Okay. So again, when you put a minus in front, the way the book calls it, it's a reflection in the x-axis. Okay. Any questions? Ashley? No? Sandy? Somebody's got to have a question. Even my knuckleheaded 6 block had a question here. Yeah. Yeah, I mean, if you're plotting points, then well, if you do it by plotting points, the one point you have to know for sure is the h. Right? You got to know where the x-coordinate of the vertex so that you get the right points in your x values. The rest of them will just happen when you plug them in. Yeah. There's more to come. We're not done yet. I mean, the question has come up, what about a reflection in the y-axis? And there is such a thing as a reflection in the y-axis. This is how you do a reflection in the y-axis. We don't really deal with it much, but reflection in the y-axis. That would be like doing this. F of x equals the absolute value of negative x. If you put the negative inside, that would flip it across the y-axis. Now, what would that look like for our v, our parent function v, if you flipped it across the y-axis? It'd be what? Everything would be the same, right? It would look exactly the same if you flipped it across the y-axis. That's why absolute value is not a great function to show reflecting in the y-axis. And honestly, usually in Algebra 2, we don't mess with that much. We mess with it a little bit in pre-calculus, But even then, not much. It causes more confusion than it's worth. So I don't anticipate that we're going to use that here, and it's not going to impact us in terms of SOLs or anything like that. Okay, so reflections. Describe the transformations. So in this equation right here, we are transforming the parent function by this subtract 2 and this minus 3. Describe what we're doing to the graph by each one of those. That's what this means. Describe the transformations. What does the minus 2 do? Right 2. Remember, minus inside means right 2. So that's what you have to say. Right 2. Okay, what is the minus 3 afterwards doing? Down 3. Okay. Okay, so now let's draw our V, right? Our V is going to be the exact same shape. It's just going to be moved around by those two numbers, right? Right 2 would put it here. Down 3 will be here. And now draw yourself a V where the right side is the slope of 1 and the left side is the slope of -1. Right? And it says sketch the graph. When you get this kind of problem, you don't want to see a table of values. This is not about table of values, right? This is about understanding the parent function and how the transformations work. So don't start plotting points. Draw your V in the right place. What are the coordinates of the vertex here? What are the coordinates of that point? 2, -3, right? So that the vertex is 2, -3. Right. What is the equation for the axis of symmetry? Remember, which would be this vertical line. It should be, it's a vertical line. Vertical lines are always x equals a number. What number? Yeah, it's got to be this one, right? It's going right through the vertex, which has the x coordinate of 2, so x equals 2, right? Every point on this line has an x coordinate of 2, x equals 2. Good. And this is an example of the kind of thing that, we're going to do over and over again. We want to make sense of this, and then to be like, how many of you have taken a foreign language now? Probably almost everybody, right? It's like conjugating a verb, right? Once you know what the stem is, then you know what the ending. I speak Italian, right? I tell you that like with an AR verb, it's parlare, parlo, parli, parla, parliamo, parlate, parlano. Now you give me another AR verb, I know it instantly. You just piece it together instantly. You don't have to like think about it. Somebody can make up a word. You want to know a make-up word they kind of have there, which is definitely not in the old Latin text anywhere. For chatting. You know what their word for chatting is? Chattare. They just made it up. They even spell it wrong because in Italian a CH would be k, not ch, but they spell it CH and they say it like they shouldn't say it, but then they conjugate it just like any old AR verb. And that's it, Once you know how this stuff works, I can throw a exponential or a logarithm or trig function. It's always the same. Always the same. Okay, so try this one. First, we'll describe the transformations, and then you can graph it, right? Tell me what's this plus 2 inside going to do? And what is the plus 1? Left 2, up 1. So try to sketch yourself a graph. Left, up. You're trying to go, oh, that's a parent function, okay. That's 2, up 1. So which quadrant is the vertex in? Right. So if you go left 2, up 1, that's second quadrant. 1, 2, 3, 4. What is the value of H? -2, right? And what is the value of K? +1. And the V goes like this. So the vertex is, the vertex, -2, +1. What is the equation for the axis? It's an equation, right? Got a variable in it. X equals -2, right? Right, it's this thing. They're the same. Good. We're done. Okay, describe the transformations in this one. Yes. Right 1, up 3. Right 1, up 3, and then the minus in front, the flip. Okay, so try to sketch that graph. Flip. Right. Up. Go to the point, and then sketch yourself a V. Which direction is the V going to open? Because it's flipped, it'll open down. Which quadrant is the vertex in? Trevor? First quadrant? How many said first quadrant? Don't whistle. If you go right 1 and up 3, which quadrant are you in? 1. 1, 2, 3, 4. So here, go up, there's the V. Okay, again, if you look at it like, here's the standard equation. AX minus H plus K. Okay, don't do that with the bottle or throw it away. So H is +1, right? The minus is part of the formula. H is 1, which is where we put it. The K is +3. So here's our V. And let's say the vertex is, why does that do that? The vertex is 1, 3. The axis is okay. A vertical line is not 1. If you don't say x equals, it's not a line. Major points taken away if you just say 1. It's x equals 1. Believe me, you're going to have plenty of horizontal and vertical lines on the test. And if you say like 1 or 2 or 3 without an x equals or y equals, I'm pretty sure for about half of you, it's because you really don't know. Like I said, a lot of you, if I said which is horizontal and which is vertical, would get it wrong. I mean, I've had that before in Algebra 2 classes where about 50-50 would guess right. Well, you could guess anything that's only got 2 answers, 50% right, and that's about what we were getting. It was mostly a guess. So you've got to know that that's a vertical line, and you say it with x equals a number, and that's a horizontal line, and you say it by saying y equals a number. Right? Very, 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 very basic stuff. Now, if you were in a regular Algebra 2 class I taught earlier today, you would have stopped there. But you guys get more. Okay. Now, what are we going to do? We're going to graph 2 times the square root of x, or the absolute value of x, and see what happens to the graph. Okay. So I'm going to use the same 5 points, -2, -1, 0, 1, 2. So when I put in the -2, the absolute value is 2. And then I multiply it by 2, and I get 4. So essentially, it's going to double all of my y values, right? So this will be 2, this will be 0, 2, and 4. -2, 4. -1, 2. 0, 0 is still on there. 1, 2 is on there. And 2, 4. Okay, do we see the V? Yes, we do. So let's draw in our V. Oh, I don't want that. I want this. Right. If you had to choose a word to describe how it changed the V, what's that? Thinner? Okay, meaning that it took it and it kind of moved it in like that? I don't think it's a bad choice of word, but it's not the word they use. Anybody else got a guess? What's that? A fluctuate? Not a fluctuate. The word that they use is stretch. It stretches the graph by making it go up faster, right? As you get away from 0, it's going up faster, away from the x-axis faster. That's called a stretch. And what is the slope of each side of the V now? What's the slope of the right side of the V? It's 2, right? It's going up 2 over 1, up 2 over 1, up 2 over 1. And on the other side, it's -2, up 2, left 1, up 2, left 1. Right? So it changes. That's called a stretch. And I've never seen it called anything else. Okay. Just a second. I neglected to write this in, but it's fine. Let's do this. Sketch the graph. Y equals 1/2 the absolute value of x. X, y equals f of x. And we're going to use the same 5 points. -2, -1, 0, 1, and 2. All right, when I put in -2, right, the absolute value is 2, and then I multiply by half, and I get 1, right? So it's going to cut all these in half. 1/2, 0, 1/2, 1. So let's graph those points. All right, that'll be 1, 1/2, 0, 1/2, 1. Do we see the V? Absolutely, the V is right here. And that looks pretty good. What word might you think that they would use? Since we've just used stretch to say when it goes up faster, what would we use if it goes up? Compress. And yeah, in pre-cal they call it a shrink. In this book they call it a compression. So, does it matter? Not really. So that's the last piece of, you know, our equation for an absolute value, for the whole family of absolute value functions, right? It's going to have it could have a constant in the front, right, which is multiplying. If that number, absolute value-wise, is greater than 1, it'll stretch the graph. It'll make it go up faster. If it's less than 1, it'll compress the graph and make it go up slower. And then we've got our minus h, which is a horizontal shift left and right, and also the x-coordinate of the vertex is h. And we've got a vertical shift, which is up and down, and the k is the y-coordinate of the vertex. Now, the ones that, you know, one common mistake that we'll make on these is if you got a problem that looked like this, and I don't think I have any to deal with, but let's say you had f of x equals negative 2 times the absolute value of x plus 3. Okay, what's going on here, right? The plus 3 is up, okay? Is this a stretch or a compression? Say again? It's a stretch. Remember, there's absolute values here, meaning that if the absolute value is greater than 1, then it's a stretch. And the absolute value of negative 2 is 2. So that's a stretch. The negative is actually making you flip it. So if you just like detach the negative from the rest of the number, consider this to be the flip, and then it's pretty clear that 2 by itself is a stretch. And so you need to be doing both. So this is a stretch. Sometimes we tend to look at it and say, well, negative 2 is less than 1, so shouldn't that be a compression or a shrink? And it's not, you know, because it's going away faster, but in a negative direction. Okay, so let's try and do all these in one. So let's see, let's describe the transformations first. The 2 is a stretch. The minus 3 is right. The plus 1 is up. So we got to do all those things, right? Stretch. Stretch, right, and up. Okay, so let's see. Minus 3, up, right 3, up 1, and now we're going to draw a V, and we got to get I'll do it like this, right? I'm going to put in the lines first, like this. This is if we were drawing the lines without the stretch. And then we'll move them. Right. So like this one here. You know, because of the stretch, it's going to move that to have a slope of 2, not 1. You see that? Up 2 over 1, up 2 over 1. Same thing over here. We're going to move this thing so that it's actually going up faster, away from the vertex. Up 2 over 1, up 2 over 1. So that's what it looks like. John? Did you have a question? Okay. Okay. Let's see. So try these. Tell me what's going on here. How many things are going on in this one equation? Compression is the half. What's the minus? Flip. The plus 2 is left. The minus 1 is down. So try to take all that into account and sketch yourself a V. Can you look on this stuff? We're not doing tables of values here, right? We're not doing tables of values here. So what are you doing? You're just doing a table of values. So it's, you know, left 2, down 1. You definitely got it opening down. Does that look like a compression of the graph, the way you've drawn it? Yeah, you probably want to make them more like that. You know. Pretty good. I mean, the only thing, whether or not you think those are showing that compression, I'm not. I mean, it helps if you like draw a little line saying this is my 1, 2, 3, 4. So it looks like you're stretching it. Who's got a good one? Okay. So left 2 would go here, not over here. Who wants to put it up there? Lee, you want to go draw it in? No. Yours is fine. Who wants to do it? Anybody want to draw it? Come on. So afraid of being wrong? Josh, you want to do it? Come on up. Okay. It's all set to draw. Take it down. So find the vertex first. The +2 means left and then down 1. So there's your vertex. Draw that in. Okay. Now it's going to open up or down. Down, right? So it's going to be going somewhere like that, but because of the 1/2, right? It's not going with a slope of 1. It's going like that. Yes. Okay. So let's see. Okay. So I mean, you've got the left 2 down 1. It opens down, right? If it has a 1/2, I mean, let's say I put the line in there, then holy moly, that's crazy. You know, it would actually have a slope like that, right? It's going up 1, left 2, and then this one should be like that. You know, so it's a positive 1/2. Up 1, right 2. Okay. So those are all the transformations that you can do, right? All of them. And for the most part, they get a little more complicated with some of the trig functions, but for the most, they work like this for all the functions. So by now, we should recognize what we mean by a parent function. At least we know one so far, right, which is the absolute value. You know, you should be able, if you were given the equation which shows a transformation, you should be able to pick out a graph, which is the right graph for that. You should be able to graph an absolute value function, not by doing a table of values, but just by applying all the transformations that we learned. Right? That's what it's all about. Given the graph of an absolute value function, identify the transformations. So if you could see the graph, could you back out, well, what were the transformations that were used? And the last one, use transformational approach, write the equation of an absolute function given its graph. Well, if you've already done here and identified all the transformations, then it should be a simple thing to like write an equation to match. So these are all related to the same thing. Fairly important. All right. Our homework is that.